We really were looking forward to seeing all the stars. We decided to call Tina for help. So this is where Tina works?
Yeah.
Let's go in. Tina is our mentor in Science Club for Girls. Okay, so this is the last flight of stairs until we reach the roof.
Oh, there's Tina!
Hi, Tina! Hey, Tina!
Hi, ladies!
Tina is studying at Harvard, and she's getting her PhD in astrophysics. Yeah, we were out stargazing, and we couldn't see like any stars.
We're not that far away from the city right now. We're at the Harvard Astronomy Department, so the idea of problems with lights, exactly what you guys just said, is a big issue, right? I'm an astronomer.
Yeah.
I want to look up at the stars, and you guys couldn't see that many stars at all, right?
Yeah.
Having too many lights around prevents you from being able to see the stars up there. But light pollution is actually a really big environmental problem, not just for astronomers. There's a lot of inefficient lighting. So the different types of bulbs that we use, and then sometimes we lose a lot of light if it's pointing upwards rather than downwards, things like that. So that's just waste of energy. That's why we call it pollution, because it's actually affecting our environment, even though it may not be something tangible like chemicals into the water or something like that. When you're looking at the Earth from space, you'll see large pockets of light glowing from the cities. You can map out entire city areas and streets from space based on that. There are very few areas that are completely dark.
Whoa, look at that! The East Coast and the West Coast. They're so bright.
One of the big projects this year for the International Year of Astronomy is called the Great Worldwide Star Count.
The Great Worldwide Star Count? Oh, cool.
I'm really excited you guys came to me with this problem that you guys had.
So you basically count stars?
Yeah, the Great Worldwide Star Count, what it's trying to do is trying to measure light pollution by counting stars. So when you're at the park, you can only see the brightest stars. So the more faint stars you can see is actually a measure of light pollution.
We're not scientists, so how can we do this?
So we can figure out a method to quantify light pollution and do this Great Worldwide Star Count, and therefore we're scientists. You don't have to have a degree or anything to be a scientist. As far as I'm concerned, you're doing experiments and you're investigating things. That's the definition of a scientist. So the constellation that I've chosen to do for the Great Worldwide Star Count is the constellation of Cygnus, which is inside the Summer Triangle. So the Summer Triangle is made up of these three stars here. So there's Vega, there's Altair, and there's Deneb. And one of those stars is actually the tip of the constellation Cygnus. So when we talk about stars and how bright they are, we refer to a magnitude system. When we're going to be talking about light pollution, we're talking about a limiting magnitude. And everyone who's participating in the Great Worldwide Star Count will be using the same system. So if there's a lot of background light, some of these fainter stars in this constellation are not going to be visible. But say we can't see any stars except the brightest star, right? And one of the brightest stars in the sky is Vega. So that will be an example where light pollution is really bad. So this would be a limiting magnitude of 1. And then going onwards, other features become visible.
1, 2, 3, 4, 5. Got it.
Eventually, so there's this interesting S-shaped pattern that happens in the middle of the cross. That too, if you can actually see that, then we're in good shape. And then, you get to a point when you really can't, just too many stars to figure out anything.